that lecture in the lab, in the WhatsApp group.
Okay, it's done. I'm recording.
Okay, fine. Okay, guys, let's start the session. But before we start the session, let me give you a quick review about the router responsibility. What's the job of the router? I will take the example from your home. I guess everyone have installed the wireless router on their premises, and it has 2 or 3 antennas at the top and 3 or 4 LAN ports, port number 1, 2, 3, and 4. And there is another port, which is WAN port, and these 4 ports are LAN ports. And you have a connection from your service provider, the ISP. You have requested for the internet access, and he terminated his line at your WAN port. And then you would be able to access the internet via wired connection, or you can set your wireless devices and you have a connection through Wi-Fi. So everybody is using that connectivity. And from ISP, where we go to the internet cloud. It is our internet cloud. And what is on the internet cloud? There are trillion of networks. Google is over here, Facebook is over here, YouTube is over here. And all the time you access Google, YouTube, Facebook, and all that networks. So we call this device, as someone says, this is wireless router. Someone says this is modem. Someone says this is the gateway. Someone says it as a DHCP server. And there are so many names of this device. Right now, we are only concerned with this particular name. If you remove the antennas on its top, we will simply call it as a router. So what this device is doing for you? Obviously, this is your LAN. This portion is your LAN. This is your LAN environment, including the Wi-Fi connectivity. This is your LAN. And over here, this connectivity is WAN. This is your WAN, wide area network. So all the time, what we are doing, we are accessing Google, we are accessing YouTube, we are accessing Facebook, and all my traffic is passed through this device. And what this device is doing, if I write a simple definition, this device, this means router, it integrates LAN and WAN. Or it's a device which forward your traffic. That means this is your forwarding device. You can call it as a forwarding device. And you can say it's a device which enable you to communicate between different network. That means router is a device which enable you to communicate between different networks. Which different networks? Obviously, over here, you are sitting in LAN, but you want to communicate some of the network in the WAN. So that means you are communicating from LAN to WAN, and response is coming back from WAN to LAN. So all the communication is done by this router, this little router. and we call it as SOHO. SOHO. That means small office. This infrastructure is SOHO, small office and home office. That means this device is for very small network. Obviously, it can accommodate 4 LAN connections only and 4 or 5 Wi-Fi connections. But in production network, in enterprise network, we have thousands of routes. We have thousands of routes because in a company, you may find 500 end users, 1,000 end users, 2,000 end users. So there is a lot of traffic which cannot be handled by this device because it has very little resources. And this device is very cheap. This device is very cheap. So in enterprise network, in production network, you need a specific device which has high-end capabilities, high-end processor, a huge number of interfaces, and this costs you to $1 million for the investment. So if we talk about this router on which we were working before the break, this router is not a cheap router. It may cost you thousands of dollars, hundreds of dollars, and it has the great capabilities, high-end processor, high-end memory, number of interfaces. So in enterprise network, in production network, we use different vendors like Huawei, Cisco, Juniper. We have different vendors in the market. So let me draw a scenario so that we can understand the basic concepts of routing. What we are going to do, we are going to perform a lab, and in that lab, I will be having one branch over here in Pakistan and the other branch at your side, for example, in Qatar. For example, these are the 2 branches of a bank. These are the 2 branches of bank, for example, Standard Chartered. So we need to perform the connectivity between them. This would be your WAN. And obviously, in this branch, there might be 100 of end users, there might be 50 end users, or there might be 10 end users. So we need to add another device, which is switch. We will talk about it later in a later session, what is a switch and what it do. But right now, this is like a dummy device. And what we can do by using this switch, we can terminate number of end users. For example, I have 2 end users over here. And this is my LAN environment. Of Pakistan branch. And obviously, there might be number of end users at this branch. So we need to add a switch, which is a layer 2 device. And there might be, we have installed a server as well as the other end users. It might be possible all the transactions is done by this server. This might be your database server, this might be your web server, this might be your application server, it could be any server, So the target is by sitting over here, I want to access this server, which is located in Qatar branch. So what we need to do, first of all, we need to perform the connectivity, which we have done. We have connect all these devices together. And then we need to assign the addresses. So that communication can be done. So I will use one network over here between these 2 branches. And for example, I will take 1.0.0.0 with /8 over here. And I will assign one IP at this interface. it might be 1.1.1.1 with /8, and I will assign the same network IP over here, 1.1.1.2 with /8. So we need to use different networks on LAN as well. For example, in our LAN, I can use 192.168.1.0 network over here. And on the other side, I will use 192.168.2.0 with /24 over here. I'm using two different networks as a private networks. So I will take the IP addresses from this network and I will assign one IP address to this machine. For example, I will assign 192.168.1.1 to this machine, to PC1, and to PC2, I will assign 192.168.1.2 with /24. Over here, I will take the IP addresses from this network, and for example, I will assign 192.168.2.1 to this machine and 192.168.2.2 to this machine, to this server. And we need to assign the gateway to these machines. And for the gateway, I need to assign the IP address on this interface, on this particular interface. And this interface is connected to the router. And I will assign, for example, 192.168.1.100 over here. The same subnet. I'm taking this IP from the same network, and it should be in the same network. And one address I need to assign over here, I will assign 192.168.2.100 with /24 over here. I hope class is with me at this point. I'm just labeling the IP addresses and the network IDs in our scenario.
We have a small question, if you allow me.
Yeah, yeah.
Now, for the default gateway, for the two routers, they are fine to be similar, correct?
Yes.
Okay. Then, can you make them, for example, easier number like 196 and 192.168.1.1, the other one 2.1 or 8.1? So it's a common number.
You can use any number. This is not prerequisite to assign the same IP addresses which I'm using right now. You can assign any, because this is the lab scenario. So you can take any addresses.
Yeah, I know I can use, but now while we are tracking, it would be better if we use this common number that we use daily. Get my point?
Yeah, your point is I should use 192.168.3.0 over here as well instead of this. That's what your point.
No, not here. I mean by the local gateway on. I don't know how I will. Okay. This is the yellow. Here. Yeah, here.
Means we should use 254.
Yeah, what I'm asking is to use 192.168.1.1. The other way, 2.1 or 8.1. To keep the router.
2.1 or 8.1. Oh, okay.
Yeah.
No problem. You can use that as well. It's up to you. It is not necessary that this should be the gateway. It is not necessary. Okay, you think this should be the better option? We can go with that. No problem. So in this network, we have three different network IDs. One is over here. Second is over here. This is the network ID. And the third one is this. This is your network ID. So we have three different networks over here. One is WAN and two different LANs, this LAN and this LAN. And what is our target? What is our task? And the task is we want these devices to communicate with the server and this end device, which we are residing in the local area network of our another branch, which is located in Qatar. So that is our task and that is our purpose to create this topology. Is that okay with everyone?
I have a question.
Yeah, sure.
Creating the IP or assign the IP address for the routers, is it has to be like 111 and /8, or we can use another type? Or
you can use any what you want actually. You want to change this network or you want this 1.0.0.1 instead of this?
so it has to be like in the first number is 1, or it has to be, huh?
The rest too. Yeah, obviously. Uh, I'm making it very simple for the other guys.
Yeah, I mean.
Okay, it would be like that, and it could be like that as well. So if you want to assign 1.0.0.1 over here and 1.0.0.2 over here, you can do that. No issue, no problem at all. Okay.
Okay.
Okay, fine. Let's build this topology and let's assign the IP addresses which we have configured over here. The same topology, the same IP addresses I'm going to configure in our simulator. So stay with me. How to build this topology and how to assign these addresses. So I'm going to remove this topology. And now already what we have done the connectivity between these two devices. All right. So what I'm going to do, I'm going to add a switch. I'm going to add a switch on both branches. And I'm going to add two machines over here. And one machine and one server over here. And first of all, we need to provide the connectivity, for example, 0/0/1 with any port of the switch. And from any port of this switch to your PC, which is the Ethernet port, and then use any port of the switch and connect it with the Ethernet of the PC. And then the same port I'm using over here with any port of the switch, and from any port of the switch towards the PC with Ethernet, and I'm taking random port of the switch and connecting it with the server. And what you need to do, you need to start these devices. Just click on the start button. And already what we have done before, we have assigned the IP addresses 1.1.1 over here and 1.1.1.2 over here before the break. So I need to assign 192.168.1. You can take any number. I'm making it simple for the rest of the guys. So 192.168.2.100 over here. So I'm going to assign these addresses. Just take the console of the router of R1. And what you need to do, simply, obviously you need to put the password. Last time we have configured the console password. So I have given Huawei as a password. No. Yes. So go to the second mode, which is system view, and from the system view, you can jump into the interface. And which interface? Interface gig 0/0/1. That interface, right behind R1. On that interface, I need to assign the IP address. IP address, for example, 192.168.1.100. And you need to assign the mask, and you can assign the mask as 255.255.255.0. And instead of this, you can write simply 24. Both are fine. Okay. Now we will take the console of R3 and we will assign the same IP address which we have decided. So go to the system view. Just jump into the interface view, interface gig 0/0/1. And you need to assign the IP address over here, which we have decided 192.168.2.100. And you need to assign the mask as well, /24, You can write 255.255.255.0, or you can write 24 simply. Okay. So now it's time to give the addresses to your end devices. I will simply access my end device and clear the screen. Okay, over here, you're going to assign the IP address to your particular end user. So 192.168.1.1, and this is the subnet mask 255.255.255.0, and you need to assign the gateway. You need to assign the gateway as well. And what should be the gateway? Whatever the IP address you have assigned over here, you need to provide that IP address as a gateway to this machine, so that if this device wants to go outside, it will forward its traffic to the gateway, and then this router will forward its traffic that where he wants to go. So you need to provide the gateway, and the gateway IP should be the same IP which you have configured over here, 192.168.1.100. So you need to sign the gateway. So the gateway is 192.168.1.100, and just click on the apply button. Don't forget to push that button. On PC2, I will assign another IP. For example, what we have decided 192.168.1.2, and the subnet mask should be 255.255.255.0. And what should be the gateway? The same gateway which we have assigned to PC1, 192.168.1.100. And just click on the apply button. And the same thing we need to do over here. I will access the PC3, and I will assign the IP address, for example, 192.168.2.1, and then subnet mask, and then the gateway 192.168.2.100. And the same thing I need to do on server side. So 192.168.2.2, and then 255.255.255.0, and the gateway should be 192.168.2.100. So that's all we have done. We have assigned the IP addresses which we have decided. And now, what was my target? My target was I need to communicate from this PC to this PC to server. I need to access that server. Would I be able to access the server now?
Now yes. You will be,
excuse me, what?
Internal.
Sorry, again, question.
Okay, can I access the server now? Can I communicate with the server by sitting at this PC? Can I communicate with the server?
I
don't. Because I have done all the configurations. Yes.
Yeah.
I think
the destination of the packet should be the server IP address, so then you can communicate.
Okay. Anyone else, please?
No, I think we cannot still, because we need to assign a port.
Okay.
To open a port for
anyone else? Okay. We don't need to open the ports right now. We need to do something different. Yes. Anyone else? I have done the WAN connection. Before the break, we have done the WAN connection. I can show you. I've done on the WAN side. If you get this command, display IP interface brief, you can see this IP I have already assigned over here, and this IP I have assigned over here. So all the configurations I have done, and my question, should I be able to communicate from this PC to server? Okay, let's try. Ping 192.168.2.2. This is the IP address of my server. And you can see the request time out. I'm not able to communicate. I'm not able to communicate.
Yeah, you should call first the other router, then to reach the server.
Yeah. Absolutely right. So why this is happening? Why this is happening? This is called routing. This is called routing. This is called routing. Right now, if I look at the routing table, if I look at the routing table of my router, which is R1, just let me show you first. How can you see the routing table? You need to put the command display IP routing table. And that means show me the routing table of this device. Okay, hit the enter. And one thing you can see, this router only knows about its directly connected networks, because we know at the right side of this device, we are running 1.0.0.0 network. And at the bottom side, we have another network, which is 192.168.1.0. And you can see the both networks. You can see the both networks, 192.168.1.0. And you can see these are directly connected networks. These are directly connected networks. And this PC is trying for what? He's saying to router that I want to go to 192.168.2.0. I want to go towards this network. And this router says, wait, let me consult with my routing table. If I'm having the information about this network in my routing table, fine, I will forward your traffic towards this network. But right now, I'm not having any information about this network. So I'm really sorry, I'm dropping your traffic because I don't know about this network. If I don't know about this network, how can I forward your traffic towards this network?
Yeah, sure.
Please mute your mics. Imad. So this is very simple. For example, let me give you the lame example. Let me give you the non-technical and lame example. For example, if you want to send me a parcel, through shipment or through cargo, so you will connect with a third party that provides shipment services, and you will go to them and you will ask them to send this parcel. This is the parcel I need to send. In real life, wouldn't it ask around the route servers about the IP address? Let me clear first, then I will respond to this answer. So whenever you go to the shipment services and you ask him, I want to send this parcel, what he will ask first? What would be the requirements?
Address.
Address. He will ask you, I don't know where you want to send it. Please give me the address so that I can make that possible. So obviously, if you ask me, sir, please call the Afnan, I will check my phone directory and I will look for the contact number of the Afnan. And what I will say, I don't have his number. How can I make him call? So I will obviously, I will apologize from you that right now, I don't have any contact number of Nan. So I'm not able to communicate with him. So that's the router claim. Okay, fine. If you want to go to this network, but sorry to say, I don't have any information about this network, then how is that possible? I forward your traffic towards this network. This is the claim of this router. So what we need to do, we need to add this network 192.168.2.0/24 in the routing table of this device. So that whenever this PC or this PC, and there might be 200 PCs, want to access this server, I should be able to know if they come and want me to send their traffic towards this network, I would be able to send the traffic. But right now, I don't even know. So we need to add this network in the routing table of this device. And in the similar way, if you want to access, if you want to communicate with PC2, and who wants to communicate? The PC3. The PC3 wants to communicate with PC2. Would it be able to communicate with PC2? Tell me.
Right now, no, they can't.
No.
Perfectly. Right now, it is not possible. How's that? If you look at the routing table of this device, if you give the command display, show me the IP routing table, you will see this device also knows only about the directly connected networks only. And these two networks, you people know very well. We are using 1.0.0.0 network over here and 192.168.2.0 network over here. This device only knows the directly connected networks. So this PC will send the traffic towards the router and will ask him, take me to this network 192.168.1.0. This router will say, wait, let me consult with my routing table. Let me find the entry against this network. And when it will look inside the routing table, you won't find any entry regarding this network. And simply it will apologize that, sorry, I cannot forward your traffic. I'm discarding your traffic because the network where you want to go, I don't have any information about this network. So what is the conclusion? Conclusion is we need to add one entry over here. Which entry? We need to add 192.168.2.0 inside the routing table. And over here, we need to add 192.168.1.0 network inside this. Then they would be able to communicate in both directions, So how we can do that? There are too many ways. But the first method which we are going to use in our today's lecture, the first method is static routing. Static routing. What does it mean? It means we will add manually. The network administrator will manually add these missing entries in the routing table of the router. So how we can do that? We need to know the syntax, how we can add the static route in the routing table. This is very simple. Just you need to understand the concept. The rest configurations are very simple. How we can add? Just go to the system view in the second mode. Let me add first over here. So the password is this. Okay, system view. You need to give a command IP route static, because I told you the first way to add a missing entry is a static route. And this is the manual configurations. Being a network administrator, I have to add the route.
Open or no need. Yes, please.
Kindly mute your mics. Okay, what I need to do? I need to provide three things. Whenever you add IP route static, the first thing you need to provide is the destination network. Or you can say the destination prefix. The first thing you need to provide. Obviously, all the communication is done on the destination networks. For example, the same example which I have discussed before, if you want to send me the parcel by the means of shipment, the shipment services won't ask you where you came from. They will be interested that where you want to send this parcel. Where is the destination? So all the routing is done by on the destination address basis. Keep remember that thing. Router do routing on which address? On the basis of destination address. He has no concern about the source address. Who is the source? He has only concern about the destination address. So first thing you need to add is the destination network, destination prefix. This is the first thing. And the second thing, you need to add the destination mask. This is a simple subnet mask of your destination. If you are using Class C, definitely you will write 24 or you can write 255.255.255.0. And right now, what is the destination? If I'm right now, I'm sitting over here. Tell me, what's the destination? Where I want to go? Or you can say, which entry is missing in my routing table? You can use both of terms. One term, by sitting over here, you can say, who is my destination? Where I want to go? Or you can say, what's the entry is missing in my routing table? So, what's the destination? Please tell me. Where we want to go?
PC3.
PC3, but this is not the actual destination. I should target the network, not the machine.
Yeah, which is, I guess,
192.168.2.0. This is my destination because this PC and this server belongs to this network. That's why I want to go this network. So only you need to tell the network to the router, not the IP address. Router do routing on the network ID basis, not on the IP address basis. So first thing, you need to mention what's your destination, first thing. And the second thing, the destination mask. And the third thing, which is really very important, Okay, fine. You are telling the router, okay, whenever I want to go on this destination and with that subnet mask, where it should forward this traffic? Tell me. I'm just telling him that I want to go to this destination with that subnet mask. But this router might have several paths. This router I'm drawing over here, the router which we named it as Pakistan, this router may have several paths from here. So if I'm adding the router, I'm telling him I want to go to 192.168.2.0 network. So by which interface it should exit the traffic, where it should forward the traffic, because he has multiple options. So what I need to tell?
Specify the device.
Subnet 000.
No, that is the default route. I'm not talking about the default route. I need to
GE.
Yes, please.
Yeah, which is GE 000.
Interface.
This interface or this interface?
No, the first router, which is
first router. Perfect.
Yeah.
You're absolutely right. But we have another option. As well. You can put, you can put two things. One, you can write your on-exit interface, which takes you towards that destination, or you can write the next hop IP address. And what is the next hop IP address? The IP address of the opposite device, which you have assigned over here on this interface. So you can write both things. You can write your on-exit interface towards that specific network where you want to go, or you can specify the next hop IP address, and always the next hop IP address is the opposite device IP address. And that interface which are facing towards you. You can write both of things. Either you can go with next hop IP address, or either you can go with your on device exit interface. So let me do this. For example, I'm taking the console of my device. This is your R1. Go to the system view. We need to go to system view, and I will simply write IP route static. First, let me put the question mark so that I can show you people. What he's asking for the destination IP, the destination IP address. So what is our destination? As we have discussed, our destination is 192.168.2.0. Then again, if I don't know how to configure this, you can take the help. Just put the space and question mark. Now what he's saying whatever the IP address, whatever the network you have mentioned, just put the mask. Just put the mask. Okay, fine. I'm putting /24. And what's the next thing? There are a lot of things. And what we can adopt, you can see he's asking for the gateway address. Okay, fine. We called it as the next hop, and the gateway as well. But gateway for which device? For R1. For R1, this is the gateway. For the PC1, this was the gateway. But for this device, towards this destination, this is the gateway. It will send all the traffic which want to go this network, 192.168.2.0 network. It will send all the traffic towards this gateway. You can call it as gateway. You can call it as next hop as well. Or you can call it as forwarding router's address. Forwarding router's address. Forwarding router's address. You can call it by 3 names: forwarding router address, the next hop, and the gateway. So he's asking for the gateway. And can you see that you can also add your on exit interface? You can also add your on exit interface. So we can do both of things, but right now we are going to provide only the next hop IP address. For example, I'm providing 1.1.1.2. So these are the 3 things which you need to provide whenever you try to configure static route. First, your destination network. Second, the destination mask. And the third one, the next hop, the gateway, the forwarding router address. And after giving this, you simply need to hit the enter button. Okay, fine. He has no issue with that. He's not giving me any error. So if you want to verify, just let me verify. Display IP routing table. So I guess people can see the change. This was the directly connected network, and that was also the directly connected network. But you can see this value over here. We have added this missing network over here, and we are not using any protocol. We have done this by static way, and the preference of this static route is 60. And what is that? We will discuss this later, the preference. But look at that. Next hop. And what is the next hop? The next hop is 1.1.1.2, the IP address of this interface. I hope class is with me at this point, how we are adding the missing entries and how we are completing the routing table. The routing table is very important. Because all the routing is done by the lookup of the routing table. Whatever the traffic comes towards the router, it will always look the routing table for the destination network. If the destination network is present in the routing table, it will simply forward your traffic. If the destination network is not available, is missing in the routing table, it will simply discard your traffic. So this is really very important. Okay, Afnan, I'm going to perform the same configurations on the other device. So it will be a recap of all the steps, what we have done. This is another chance to understand how we do static routing. Now I'm on the other branch. I'm at the other branch. So I need to add the route. Because we have seen we have only 2 networks. Which are directly connected networks. You cannot see any value like 192.168.1.0 network over here. So how to add this missing entry in the routing table? That's what we are going to do. And we want our routing table complete. So go to the system view. Just simply type a command IP route static. And then you need to add three parameters. First parameter is your destination, 192.168.1.0. This is my destination. Why this is my destination? Because right now I'm sitting over here and I want to access this network. So that's why this is my destination. Or you can say this entry is missing my routing table. First thing. The second parameter, you need to add the mask of the destination, and you can write in both ways. You can write 255.255.255.0 as well. And the last and important thing, by sitting over here, you need to assign the gateway. That if someone asks me to take me to this network, which network? 192.168.2.0 network, I will simply all the traffic towards this device, and after that this device will take care of that network, because this is 1.0. This network is directly connected to this device, and then it will take care of all the communication. It will send the traffic to the switch, and switch will identify the destination MAC address, and it will send to the PC1 or PC2. I think this is clear to everyone now. And now you need to set the next hop. This IP is the next hop for this device. For what? If he wants to send the traffic towards this destination, then this IP address is the next hop. And this is the gateway. And this is the forwarding router address. You can call it by any name. So we need to add the next hop. The next hop is 1.1.1.1 and hit the enter button. Afnan, this is clear to you? Now this is clear? Okay, fine. If you want to verify, so check the routing table, display IP routing table. So we cannot directly access the device within the different network, since we cannot use its IP address directly. Obviously, we cannot access directly. We need to perform routing. So now you can see this was my own network, which was directly connected. This was my own network, which was directly connected. Now I have that missing network in my routing table, by which means by static way. And what is the next hop? The 1.1.1.1. Now, my question is, I should be able to access the server by sitting at PC1. Can I access now? Can we do that?
Yeah, I think now we can.
Yes.
Yes.
I want everyone to reply. If someone have still doubt, he can tell me. Okay, fine. Let me access this PC and let me ping that server. And now you can see the reply is coming from the server. You can read this reply from 192.168.2.2. With all the replies I'm getting from server. That means I can communicate with the server now. And if this machine wants to communicate, obviously it can also communicate ping 192.168.2.2. You can see the replies coming. And if you want to communicate from this branch towards another branch, you can do that as well. You can do the both way communication, ping 192.168.1.1. Sorry, I have written the wrong IP address. So ping 192.168.1.1. I'm pinging to PC1. You can see the replies coming. If you want to ping to another PC, obviously you can do that as well. So that is called static routing. Static routing.
I do have a
Which we
question,
have.
if you don't mind.
Sure, sure.
Is it okay to have some loss? It is written that there is 20% loss, packet loss.
Yeah. When you attempt first time, whenever you attempt first time after a specific duration, you will see one packet usually dropped. But now you can see there is no packet dropped, and you can continue to ping. You will see no packet is dropping. And the first packet dropped because there are some switching concept which is related to your ARP, address resolution protocol, and there is a resolution of IP address against a MAC address. IP address is resolved by the MAC address, and for that purpose, we lost a packet. We lost our first packet, and once it's done, we don't lose any packet. So this is some switching concept. We will discuss this later when we will start switching. So this is not the part of our topic right now, but I'm telling you the reason. There is some mechanism of address resolution protocol which resolves IP address into MAC address, and by resolving this on the first attempt, the time is expired and the first packet is dropped. I hope
Great,
this is clear
thank
to you.
Yeah, great, thank you.
Thank you. How did we choose the next hop? For example, if I have another branch over here in Dubai, for example, I have another branch in Dubai and the same LAN over here, the same LAN, this is the switch, and there are end users over here. So definitely, I won't be using the same network over here. Over here, we might be using 2.0.0.0 and 2.1.1.1 and 2.1.1.2 over here. And for example, over here, we are running this network 192.168.3.0 network over here. So now I have added a route for this network. I need to add another route to this network. So what would I do? I will simply route IP, route static, then I will write the destination. Destination is 192.168.3.0 at this time, because this is the destination, and the destination mask 24. And now you tell me, what should be the next hop? By sitting over here, and to go to this destination, what should be the next hop?
We have to select
write the gateway
interface.
Exactly, this interface.
Yeah.
This interface. And if you don't want to write the next hop, you can use your own exit interface. For example, this is your gig 0/0/0, or you might be using gig 0/0/2 over here. So instead of writing the next hop, you can write your own destination, because you know this interface will take you towards this destination. If you write this interface instead of next hop, you know this interface takes you to this network. So both are valid solutions. Both are valid solutions. I hope this is clear to everyone.
Yeah, it's clear.
Okay, so our today's topic was basic device navigation and configurations, the basic CLI introduction and their modes and the basic commands. Then we are discussing right now introduction of routing and static routing. So we have performed static routing, and what else you can see by configuring the static route. These are the stuff. Officially, we don't recommend slides. We simply write the stuff and deliver you the concept. But these slides are for you people. If you want to read all this stuff which we have discussed, you can do that. But let me tell you the drawback of static route. Let me tell you the drawback of static routes. There is question. Okay, fine. This is clear. So static routing is for small size network, for small size network. You cannot handle static routing in a large or enterprise network, because it's get very complicated for you to set the next hop, the exit interfaces, the destination IDs. You need to know all the information about your infrastructure. For example, if you have 500 branches, you need to know all the destination networks, the next hop, the exit interfaces. This will make you very hectic. So only we implement a static route in a special scenario. And the other reason is why we don't prefer the static route in a large scale network. For example, if you take an example, if I'm having such kind of topology, such kind of infrastructure, and these are my different devices which are connected by this way. And for example, this is my source. This is my source, and where I want to go, this is my destination. This is my destination. So by sitting over here, I have two options, just like the Google navigation. Whenever you want to go somewhere, you activate your Google navigation, you put the source and you put the destination, and the Google navigation show you the route, and it will always provide you the best path towards the destination. So right now, being a network administrator, I have two possible routes. I have two possible paths. The path one by this way, and this is our path two. So being a network administrator, I will calculate different stuff, and I have to know which should be the best path. There might be 100 megabit per second bandwidth, and there might be 10 megabit per second bandwidth. So I will suppose this might be the best path because the bandwidth is high over this path. Okay, fine. I will configure the static route towards this destination by this path. Okay, fine. I have configured that path. And now I'm not here. I'm not in my place. I have to go somewhere else. But after some time, what happens? This link goes down. This link goes down. This device goes down. This device may go down. This link may go down. So what will happen? All the traffic which I was forwarding by this path will be discarding because the link has been down. The same thing when you don't have the internet access at your home, you won't be able to access the Google, your Facebook, your WhatsApp, and all the stuff because the link has goes down. So the traffic will not be migrated towards another path automatically. It will not adopt the other path automatically because in static routing, we are not running any protocol. In static routing, we don't use any protocol, no protocol running behind this scenario. So what you have to do, you need to add immediately another route by the same way like we was doing before, IP, route, then static command, then destination, then mask, and then the next hop, and it will take time. For example, it takes 5 minutes. This duration is not acceptable in today's network. 5-minute delays. No, this is not acceptable. This is a huge delay. So that's why we don't recommend static routes in the large and enterprise network. Did you get my point?
Yes. Yeah.
Yes.
Okay. So, for example, let me show you one thing more. As we have discussed these parameters, basic of static routes, you need to provide the destination address and the destination mask, and you can add the next hop IP address, or you can add the outbound interface of your own device, and the important thing, the static route preference. And what is this preference? What is this preference? I have shown you this parameter in the routing table as well. Can you see? I have shown you this parameter in our routing table, this one, the preference. What is this preference? By default, whenever you configure the static route, by default, whenever I say by default, that means we can change that parameter. But right now, this is by default, and by default, this is 16. The static route preference, by default, this is 16. So what does that mean? That means, for example, look at this diagram. Again, the same kind of topology. We have router A and we have router C. This is your source and this is your destination. And you add two routes, the static routes, but with the same preference. One route you are adding from here to here and the other route you are configuring from here to there, but with the same preference. Then what will happen? They will provide you the load balancing. This router will send 50% traffic over this link and 50% traffic over this link. This is the load balancing you can achieve by configuring the static route by this way. And for example, if the preference is different, make it clear. If the preference is low, then the priority of this route is high. And if the preference is high, the priority of that route will be low. What does that mean? That means if you have the same topology over here, and you have configured two static routes, over here you are setting the preference 60, the preference is 60, and by this way you are setting the preference 100. So initially this router will prefer this path as the best path because it has lowest preference and the lowest preference has the highest priority. All the traffic will be forwarded through this path. But what is the advantage of adding another static route with the highest preference? For example, if this link goes down, your traffic will be forwarded to this path because you don't have any other option. So this is not automatically shifting the traffic. We have configured two static routes, one with preference 60 and one with preference 100. So initially it will forward all the traffic by this path because the preference is low. If the preference is low, the priority is high for this route. So it will send all the traffic by this path. But if this link somehow goes down, immediately it will add another route into the routing table and will forward all the traffic via this path. That's how we can achieve load balancing and route backup. This is the route backup diagram, route backup. We are using the backup over here. And over here, we are performing load balancing. I hope class is with me at this point.
Yes.
Just sorry again, the 60 has a higher priority, right? Than 100.
Yes. The lowest the preference, the highest the priority. The highest the preference, lower the priority. This is the reverse case. So there is another type of static route which we call it as default route. Let me open my board. What I'm saying default static route. For example, I'm taking the scenario of your home as we have discussed before. If I'm having a wireless router at my home on my premises and I'm having 4 LAN interfaces and 1 WAN interface, and from 1 WAN interface it is taking me to my ISP and ISP taking me to the internet cloud. Okay, fine. And I'm sitting right over here. And all the time what I'm doing, I'm opening my internet browser and I'm writing www.google.com, and sometimes I write youtube.com, and sometimes I write facebook.com. And where are these servers? They are on the internet. For example, this is the Google server which has an IP address 8.8.8.8. For example, this is the YouTube server. For example, this have 7.7.7.7, and this is the Facebook server which might have 6.6.6.6 IP address. I'm considering it randomly. These are the not perfect. This might be perfect, but these are the not perfect IP addresses of these servers. So all the time I'm sitting over here, I am simply writing in the URL www.google.com, and DNS resolves this name into the IP address. You know what is the domain name system? It resolves the DNS name into the IP address. So I asked my router that I want to go to 8.0.0.0. So what will happen? It will check its routing table, and it will see if the entry is available in the routing table. It will simply forward my traffic. If you don't find any entry in my routing table against these millions of networks, it will simply drop my traffic, isn't it? Can I add all the millions routes into my network device, which is for the cost of, for example, $100 or $50? Can it manage all the billion and trillion of routes into the routing table? No, it's impossible. Have you ever done this? Have your ISP done this to your wireless router or simply router? No, it seems impossible. It has minimum resources. This device don't have much sufficient memory to add all these routes. No, this is impossible. So what we need to do, we need to add the static default route. This is the default route. Remember, when we were discussing the IPv4 addressing scheme, and when we were discussing the class A range, what I have told you, I told you the commercial range is 1 to 126, but the actual range is 0 to 127. And I said 0.0.0.0 is reserved for default route. And that is the default route, 0.0.0. This is reserved for what purpose? For example, in the same scenario, I will write a command IP route static the same way. But at this time, I won't be writing any specific destination, but simply what I will write 0.0.0.0. What is the subnet mask? I say 0.0.0.0. Because I don't know the destination. I'm telling my router, if I want to go towards any destination, 0.0.0. means towards any destination with any next hop, send the traffic towards the next hop. And at this time, the next hop is your ISP site. And what is the address of ISP? It might be any address. For example, we are writing 1.1.1.2. And if you don't want to write the ISP as a gateway, you can write your own outbound, your exit interface. So this is called static default route. And it reduces the size of routing table. Instead of having the millions of networks, I can add only one route instead of millions of networks. And it will send all my traffic. He will say, I don't care, I don't know where you want to go. I'm just forwarding your traffic towards ISP, and everything. ISP know everything. He will take you towards that destination where you want to go. But this is not for me. I cannot do that for you. So that's why we configure static default route. And how we can add that route? Let's do the lab. I need to form the configurations. Okay, let me delete the route which we have added before. And you should be able to delete the things which you configure. So to delete the specific route which we have configured first, so undo IP route static. If you don't agree, okay, write the destination 192.168.2.0 and /24. Okay, so we have deleted the previous entry which we have added by static route. If you want to verify, show, verify this, display IP routing table. You can see the entry has been removed from the routing table. Now you can only see the two network IDs which are directly connected. We have removed that entry. So we need to remove that entry from here as well. So, okay, fine. Don't remove this entry. Why? There is another practical scenario which I want to elaborate. Take this device as your ISP. Take this device as your ISP. And this is your company's edge router. This is your company's edge router. And why we call this edge router? Because its one interface is facing towards the ISP and the other interface is facing towards my private network. So we call it as edge router. We call it as edge router. So normally what happens, from my side to ISP, we configure the default route, IP, route, static, and then I will write 0.0.0.0. Then I will write 0.0.0.0, and I will set the next hop 1.1.1.2. These configurations are from my side, from my edge router. And from the ISP side, if you are a little company, if you are a small company, the ISP will configure the static route towards your device. And that's what we have done. IP, route, static, and then what we have done, we have added the destination 192.168.2.0 and the subnet mask and the next hop 1.1.1.1. This is the practical and common scenario in our network infrastructure. So from ISP to oversight, ISP configure the static route, and from oversight to ISP, we configure the static default route. This is the practical scenario. So that's why I'm not deleting the static route from ISP side, but right now I will configure the static default route at my side. I hope class is with me at this point. This is really very important scenario. If someone asks you where we configure static route and where we configure static default route, you should be able to give the answer. Yes, this is clear to everyone.
Yes.
Okay. So how we can add the default static route? This is very simple. IP route static destination towards any destination 0.0.0.0 with any subnet mask. You need to set the next, which is 1.1.1.2, and this is your ISP site. Just click the enter. You want to verify display IP routing table, and you can see the static default route has been added into your routing table with the same preference. The preference is same for the static default route. And now I would be able to access the same server. Let's see. Go to your PC. And this is the IP of our server. You can see the reply is still coming. And this is the real scenario. This is a practical scenario. You can see the reply is coming. I hope class is with me at this point. So that's all about IP routing introduction. And we have discussed static route. We have discussed static default route as well. Yes, class. I guess people are sleeping. People are sleeping.
No, wake up. You are awake.
No, you're not sleeping.
I'm not getting any response from you people.
It's clear.
And it will demotivate me. Can you listen my voice?
Yes,
Yes,
yes.
yes, we
Yes.
can.
It has a spark. It
Clear.
has a
This
spark.
was you.
Yes, yes.
So why you are getting lazy? Even you people are simply listening. I'm continuously speaking. You are simply listening. Stay active. Stay active.
Just digesting the new information. That's it.
Thank you. Okay, fine. So that's all about the introduction of routing and IP routing and the static routing, all the stuff I have discussed with you people. You people can read the slides and you will get all the things into the brain because I have discussed all the stuff, But as we have discussed, we don't recommend static way to achieve the convergence. One thing is missing. I should tell you people. One thing is the one word which is really very important and technical term, that is convergence. Convergence. Why we are doing routing? Why we are doing routing? ISP is your internet service provider, the company which always provide you the internet, and you are enjoying your social media activities and you are watching movies. This all credit goes to your ISP. So don't forget about the ISP. Who is ISP? Yes, internet service provider, which provide you the services of internet.
Just to make it clear, it's like Zain, Viva, yeah, Orido, Fastelco, Coordinate. Those are the
There are
companies in
so
Kuwait.
many. There are so
Yeah.
many ISPs.
I'm just mentioning the companies in Kuwait.
Yeah. Okay. Thank you. Because I don't know the ISPs from your side. Although my elder brother, his name is Fawad Amir. Right now, he's in Qatar, and he's in Qatar since 6 months, 6 years. So he's a project manager over here, and we have another branch in Qatar with the name of Dicotic. This is the other branch of Kuwait. This is Dicotic, and he's working over there as a project manager. And they have a big project of Ashghal. Maybe you people know about the Ashghal. Do you know? Anyone know?
We are in Kuwait, not Qatar, so don't know.
Someone, obviously, someone might be there in Qatar. No? No one belongs to Qatar? Because my company asked me.
I believe all of us are from Kuwait.
Yeah, all of us.
Okay, fine. Because my company said to me that this training is from Qatar. So I was assuming that you all people belong to Qatar. Okay. Then forget about this. Okay.
The packet loss from your company. Yeah.
Okay. So we have discussed that static route is for small size networks. For enterprise network, we use dynamic routing protocols. We use dynamic routing protocols. In all the scenarios, you will be listening two words. First one is static. The way of doing a common thing is by the static way, or you can do this by the dynamic way. So whenever you hear this word, the word static, that means manual. That means by the network administrator. That means no protocol is running behind these configurations. And whenever you hear this word manually, dynamic means auto. Dynamic means auto. In dynamic mode, all the configurations is done by the network administrator, but we run different protocols behind that scenario. So over here, we have dynamic routing protocols, and we have number of dynamic routing protocols. For example, we have dynamic routing protocols of two kinds. One is IGPs, interior gateway protocols, and the other type we have that is exterior gateway protocols. The protocol which are running in the same autonomous system number is called IGPs. And what is the autonomous system number? Like you have the public IP address, in the similar way, you can get the autonomous system number from your ISP. This could be public or this could be private, but simply the AS is the collection of networks, and which are running the same routing policies. For example, in IGPs, we have number of protocols. For example, we have RIB over here, we have OSPF, we have EIGRP, and we have ISIS over here. There are number of IGPs protocol, but all the IGPs protocols belongs to the same autonomous system number. And there is another category, which is EGP, Exterior Gateway Protocol. And in Exterior Gateway Protocol category, we have only one big protocol, that is BGP, Border Gateway Protocol. And we will be discussing this protocol in our session, but I guess in third session or fourth session, I guess in third session, we will be discussing that protocol as well. But for right now, IGPs are run inside the same autonomous system number. But if you have two autonomous system numbers, for example, you have AS 100 over here and AS 200 over here, AS 200 over here. If these two autonomous system wants to communicate with each other, they need to run the EGP protocol, Exterior Gateway Protocol, which is only one-on-one BGP. And so we don't understand what is autonomous system numbers. For example, this is the ISP1, Internet Service Provider 1, and this is ISP2. All the traffic from one ISP to another ISP, from the other ISP to another ISP, they all recognized each other by their own autonomous system numbers. And again, these autonomous system numbers are public, which has purchased by the IANA. IANA also deal with the IPv4 addresses as well as with the autonomous system numbers. Is that clear to everyone? Because the ISPs exchange millions of routes with each other, so they don't recognize each other by their IP addresses. They identify each other by their autonomous system numbers. This is another number scheme. This is another addressing scheme, which is in the simple, in the integer values. Is that clear to everyone? So why I'm dealing all this stuff? Because we are going to start the dynamic routing protocols, dynamic routing protocol, and in the dynamic routing protocols, we are going to discuss the OSPF. Why we are using this dynamic routing protocols? Because static route for the small size network, but all the dynamic routing protocols are for the large and enterprise networks. And what are the beauties of dynamic routing protocols? For example, we have discussed this kind of network in the static route. For example, I'm discussing it again. This is my source and this is my destination. And to go from source to destination, I have two possible routes, path 1 and path 2. If I do the configurations by static means, if I configure the static route, if this thing goes down, all the traffic will be discarded. Automatically, all the traffic wouldn't be forwarded to another path. But the beauty of dynamic routing protocol, the beauty of OSPF is, if OSPF has selected this path as the best path on the basis of bandwidth, for example, over this link, we have 100 megabit per second, and over this link, we have only 10 megabit per second. So OSPF will choose this path as the best path and will send all the traffic by this path. But in case somehow, if this link goes down, all the traffic immediately will be forwarded by the OSPF to another route. All the traffic immediately will be forwarded to another route. It will automatically adopt another possible route. For example, in the Google navigation, if Google tells you this path to source to destination, but unfortunately you miss that right turn and you go straight, what Google navigation do? It will provide you another path. Then you can go towards this path. The same scenario. Because in the Google navigation, in the backside, we are running different algorithms. We are running different codes. Why you always just draw two paths? I can draw so many paths. So I don't want it to be complicated for you. So that's why I'm just drawing two paths. You can add another path if you have problem with two paths. So lo and behold, I have added another path, the third path. So over here, there might be 50 megabit per second bandwidth. So again, OSPF will choose this path as the best path. But if this link goes on, this dynamic routing protocols automatically adopt another path. It will adopt the second best path, which provides the 50 megabit per second bandwidth. I want to see how the traffic transfer. Okay, I will let you show. So regarding the OSPF, we need to start another slides. I will share these slides with you as well. So what is OSPF? Introduction to OSPF. OSPF is a open shortest path first. The abbreviation of OSPF is Open Shortest Path First protocol, and it is a link state protocol, and this is the interior gateway protocol. This belongs to IGP category. If you remember, I have drawn two categories, IGPs and EGPs. So OSPF under which category? Under IGPs category. So developed by the IETF, Internet Engineering Task Force. This is an organization, and we have two flavors of OSPF, two versions of OSPF. OSPF versions 2 for IPv4 addresses, and OSPF version 3 for IPv6 addresses. So we have two versions, OSPF version 2 and OSPF version 3. Now the properties of OSPF, we need to discuss some properties of OSPF so that we have a good knowledge about OSPF. So first of all, the very important thing of every dynamic routing protocol, and right now the property of OSPF is algorithm. Why OSPF is able to calculate the best path? How it can calculate the best path? How it can calculate the best path, although it has having so many paths to go to destination? Because behind this protocol, there are the algorithms which are very complicated, They calculate, absolutely right. You are absolutely right. They calculate the cost. Obviously, this algorithm calculates the cost of each and every path. And where it gets the best and the lowest cost, it will put that route into the routing table, and all the routing towards that specific destination is done by this best path. So we have algorithms in OSPF, and we call it by three names. One name is SPF. You can remove the O from here, and you can write it SPF. Shortest path first is the first name of the algorithm of OSPF. The second name is Dijkstra. J is silent over here. Dijkstra's algorithm. Why we call it Dijkstra? Because the scientist which developed this algorithm, his name was Edgar Dijkstra. Edgar Dijkstra. So this name is by the name of that scientist, Edgar Dijkstra. And most probably, he introduced this algorithm in 1959, I guess. And the third name which we give to the algorithm OSPF is LSA. LSA means link state algorithm. So we call this algorithm by three names. We can say SPF, we can say Dijkstra, or we can say LSA, link state algorithm. Why we call this protocol is the link state protocol, we will discuss in few minutes. Why we call it as link state protocol. Anyhow, the second property is this is an IGP protocol. This is an IGP protocol. This is under the IGP supervision. And the preference value by default of OSPF is 10. And if you remember, I have told you the preference value of static route, which was 60. And the OSPF, in OSPF, this is 10. So you can compare that. You can compare that in the router. If we are receiving the same routes from OSPF and the same routes from the static route, this router will give the preference to whom? To OSPF or the static route? Please.
Static route.
No.
It will go to the lowest.
No, I mean
to the
OSPF.
OSPF.
Yeah, you mean OSPF.
yeah. Sorry, yeah. OSPF.
No problem. No problem.
The priority is for the lowest.
Yes, the lowest the preference, highest the priority. Highest the priority. Okay, so that's mean by preference. Okay, move on. The fourth property is routing updates. Routing updates. So let me give you a brief explanation what is routing updates. When we were talking about the static route, like we were having this kind of topology, R1 and that was R2. Now I'm not writing Qatar over here because that was misconception. Okay, we were discussing this topology. Here we were running this network 1.0.0.0/8. Over here we were running 192.168.1.0, and over here 192.168.2.0/24. By using static routes, we need to know about so many stuff, about the destination, about the next hop, about the outbound interface, about the preference. There was so many stuff. But whenever we run IGPs means right now we are talking about OSPF, what we need to do? We will simply enable OSPF. We will simply enable OSPF. We will trigger OSPF. We will activate the OSPF. And what I will say to OSPF, please advertise my network by giving the network command. Advertise my network, for example, 1.1.1.1. Advertise my network, advertise my this network. And I will say simply network and advertise my this network 192.168.1.100. I will simply say advertise, please advertise my link state advertisement. Okay, fine. Over here, I will simply say, please OSPF, activate yourself and advertise my network. Which network? Obviously, we have 1.1.1.2 over here, 1.1.1.2, and network 192.168.2.100. What I'm doing? I'm simply saying my router. I'm just simply triggering OSPF, and I will say to OSPF, please advertise my these networks. With whom? With my neighbor, which is my directly connected. Okay, fine. The OSPF will say, okay, I'm sending these routes to your neighbor. Fine. Then over here, I'm running the same protocol, the OSPF. I will trigger the OSPF and I will ask the OSPF, please advertise these networks to my neighbor. And what will happen? All the routes which are over here, which are running over here, and all the networks which are directly connected, I'm advertising these routes to my neighbor, and my neighbor also exchanging these routes with me as well. So consequently, what will happen? It will complete its own routing table because already he has his own routers, and the left routes it will receive from the destination. And this router already have its directly connected networks, and the rest of the networks, to complete the routing table, it will receive all the updates, all the routing updates from its neighbor. And in the result, both router will complete their routing table. So we call it as routing updates. We call it as routing updates. In OSPF, we call this routing updates as LSA. And what is LSA? This is link state advertisement. This is link state advertisement. You got my point? This should be clear to everyone. This should be clear to everyone. This is really very important discussion. So the fourth property is routing updates. What does it mean? That means routing protocols share, advertise information about the best path or share routing table with others. What I'm saying routing update means all the router share or advertise the information about the best path to each other. This is meant by routing updates. But in OSPF, its advertisements is known as LSA, link state advertisement. And why we are calling again and again as a link state, that OSPF is a link state protocol. OSPF is a link state protocol. Why we call it as? Because link, that's the interface of our router. For example, I'm sitting right over here. So this is my interface, which connect me to my neighbor, First thing. And why we call it state? Because the description of this interface and how it is connected to the neighbor routes are exchanged by this device to this device. That's why we called it as link state protocol. And the link state routing protocols operate by you sending link state advertisement to all the other link state router. What does it mean? That means if I'm having 3 routers over here, what will happen? This router will share its link state advertisement with its neighbor, and this router will share link state advertisement with its own neighbor. Excuse me. So the both routers are exchanging link state advertisement to each other. And once they get the link state advertisement, what they do? They create the link state database. The link state DB, the database. All the router will maintain their own LSDB, link state database. And what would be inside this database? Obviously the routes, all the information about their neighbors, all the information about the routes. But how they can, for example, let me clear the screen. we have two routers over here. And in both of the routers, we start running OSPF. And initially, they don't have any data in their LSDB, in their link state database. Both will share LSAs with each other. LSAs means the information about their interface and about their network. It will exchange the information with him, and this router will exchange its own LSA with him. In CRAS, what they will do, they will create their own LSDBs, link state databases. Get my point?
Yes.
Fine. So, link state routing protocols operate by sending each other the link state advertisement to all other link state routers. That's how they perform convergence. And that's how they complete their routing table. So we don't need to bother about the destination. We don't need to bother about the next hop IP. We don't care. And OSPF uses two multicast addresses for the advertisement. And why these two different multicast addresses? Can you see? When we were discussing IPv4 addressing scheme, and when we reach at class D, I said this is for multicasting purposes, and we will talk about it later in our session. So that's the time. You can see this IP belongs to which class? Obviously, this belongs to class D. And class D is reserved for multicasting. Obviously, there are a number of protocols in the network. So some of the addresses are reserved for OSPF, some addresses are reserved for RIP, some addresses are reserved for ISIS, some addresses are reserved for BGP. So there are a number of protocols, and they use class D addresses to communicate with each other. And they use multicast addresses to communicate with each other. Because these are the routers, these are the machines. So machines use these addresses to communicate with each other. Now the important term related to, guys, would you like to have a break or I can continue? It's up to you people.
For me, I will prefer break.
You prefer break?
Okay, break would be better.
Okay. Let's have a break because my throat is also somewhat dry. So let's have a break, and we will be back. How much for the break? How much time for the break?
How much time we have left?
How much time we have left? I guess hours. We are still having 3 hours left.
Okay, so if the break is 1 hour, it's too much for 3 hours.
I guess you people
That's why I asked that.
I guess you people are get tired, isn't it?
We got tired.
I can understand. Okay, after the break, I will try my best not to discuss theory as much. We will start lab on OSPF. But obviously, you know, when we start something new, we need to discuss the basic and the fundamentals. Then we can move towards the lab portion. So it is impossible to start directly lab without discussing the fundamentals. So I need to discuss the fundamentals. So after the break, we will take 30 minutes or 20 minutes, and then we will start lab on OSPF. Okay. So so let's have a break. I guess let's take a break of 45 minutes so that we can manage their own business, isn't it? So let's take a break of 45 minutes. Perfect. You guys agree?
Then
Yes, sir.
Yeah, perfect.
We're back at what time? Yani?
2:45, I think.
2:40.
Yeah, 2:45. Okay. From your side, 2:45.
Yeah, 2:45.
Okay, we'll see you guys after 45 minutes. Take care.
No, it's better for you to write here the time.
Okay. Let me discuss. Okay, I can write over here as well. We will discuss some basic and fundamentals of OSPF. Then we will start lab in of multi-area OSPF and single area OSPF lab. Manna, is it clear?
Yeah, it's clear.
Okay, fine. So I guess people are much tired.
Use the time before we start so you can send this presentation on WhatsApp.
Yeah, after the end of the session, I will definitely share with everyone.
No, because I am writing on the slides, so it is better.
Okay. Just give me a second. I'm sending right now.
Thank you.
Okay, I guess I have already attached an email.
Maybe then for tomorrow you put everything in a zip file and everything. It's better, maybe.
All right. Okay, check your inbox. I have sent on WhatsApp group. So before we discuss a lot of stuff, and these stuff are very dry. So let's prepare the lab and let's see what we need and what nut and bolts we are required for the lab orientation. So there are some necessary things which you need to understand before we jump into the lab. So let me draw the topology and then I will explain each and every term which we need for the lab purposes. So let me draw the lab. For example, let me add another router instead of removing this complete topology. Let me add another router. Okay, that's fine. Power. Okay, the topology is already we have configured the IP addresses on this segment, which was 1.0.0.0/8 and 1.1.1.1 over here and 1.1.1.2 over here. So we need to add another network on this side. For example, I'm taking 2.0.0.0 over here, and I will assign 2.1.1.1 over here at this side, or at this interface, I will assign 2.1.1.2. And we need to add another network on the LAN segment. So I will add 192.168.3.0 network over here. And already we have added 192.168.2.0 over here and 192.168.1.0 over here. So this is the topology which we are going to discuss. But now we want to run OSPF. To run OSPF, we need to run OSPF on the particular interfaces, on this interface, on this interface, on this interface, or on this interface. So how we will do that? We will simply configure an area. First of all, we are going to perform a lab, which is we will configure as area 0, or we can take any area. And what's the area concept in the OSPF? Area is a collection of routers. Simply, the area is collection of routers. So this is a compulsory parameter for the OSPF configurations. So first of all, we are going to perform a lab. And which lab? We are going to perform single area OSPF lab. And for that, we need two things to discuss. And what are the parameters we need to discuss? These are the parameters. Let me clear the page. Okay. First thing is process ID. And what is that? This is simply an integer value which represents the process identification. For example, whenever we will try to write OSPF, it will inquire a process ID for that particular OSPF process. And you can set any number, and the number range is 1 to 65,535. It could be any number from this range. So this simply an ID, the identification of the process of OSPF. Then comes area ID. So right now we are going to perform the lab a single area OSPF. So we will put this as any area, and it could be any number. But whenever we talk about the single area OSPF, we normally set area 0. And what is area? I told you area is a collection of routers in the OSPF domain. And what is the wildcard mask? As we have discussed 3 different classes, class A, class B, and class C. And we have learned that the class A subnet mask is 255.255.255.0. Sorry, I'm writing wrong. The class A subnet is 255.0.0.0. Class B subnet mask is 255.255.0.0. And class C mask is 255.255.255.0. That's what we have discussed in our starting session. Kindly make sure your mic should be turned off. Imad, please. Imad, just mute your mic. And the person who is appearing with the name iPad, please turn off your mics. So wildcard mask is just to flip the bits, and which bits? Obviously, we have only 2 bits, and we will flip the bits just like not get, we will flip this bit into 0 and 0 into 1. And in class A, you people can see 255 means all ones. So I will write them as 0. In the second octet, all bits are zeros. I will flip them in 1, and all ones means 255. This all 0 means 255. This all 0 means 255. And this is the wildcard mask of class A. In the same way, if you talk about the class B, you need to flip the bits. All the bits are ones, you will flip them in 0 and you will write it as 0. All the bits are 1, you will flip them as zeros. All the bits are zeros, you will flip them in ones, so you will get 255. And over here, you will get 255. So this is the wildcard mask. This is the wildcard mask of class B. And what if we talk about class C? The same thing. All ones, all zeros, all ones, all zeros, all ones, all zeros mean all ones. So these are the wildcard masks of respective classes. But what if I talk about a single IP address? If I'm having a single IP address, this is for like if you have a class C network, for example, 192.168.1.0. If someone asks what is the wildcard mask for this network, obviously you will say 0.0.0.255 because the class C wildcard mask is this. Fine. But this is the network ID. This is representing the complete network. If we talk about the single IP address, for example, 192.168.1.1, then the wildcard mask of a single IP address would be all zeros, all zeros. If I'm having 1.1.1.1, the wildcard mask of this single IP address would be 0.0.0.0.0. If I'm having 2.1.1.1 or 2, the wildcard mask of the single IP address would be 0.0.0.0.0. So that's how we define wildcard mask. Although wildcard mask takes 4 or 5 hours to complete this topic, but for the lab purposes, I'm defining it very simple way, in a very simple way. Because we don't have much time. In fact, OSPF we cannot discuss in one day. This is the big topic. This is a very huge protocol for the large scale enterprise network. So normally we take 12 to 15 sessions in normal classes to wind up this topic. Okay. So why we use wildcard mask? This is important. Why we use wildcard mask? So the OSPF network command, obviously, whenever we will provide OSPF, we will provide the process ID first, the first step. In the second step, we will define the area. In single area OSPF, we simply define area 0. And then we use a network command. And with the network command, I will simply write the interface which I want to advertise with my neighbor. And then I will define wildcard mask. And the wildcard mask we use with the network command uses as a combination of network address and wildcard mask that specifies the interface address. That means I'm simply advertising this single IP address with the network command. Obviously, you can write the complete network. For example, if you want to advertise the complete network, for example, 1.0.0.0, then you will write which wildcard mask? 0.255? Yes, excellent. Excellent. So this is the wildcard mask which defines which network or which IP I need to advertise. So it is controlled by wildcard mask. So if you are defining 1.1.1, you are running OSPF for the particular IP address. The beauty of OSPF is you can run OSPF on single IP address, or you can advertise the complete network. So whenever you try to advertise the single IP address, you will put this wildcard mask. And whenever you try to advertise the complete network, you need to add the wildcard mask for the whole network. So that's why we are specifying wildcard mask. And then, the area ID, I have discussed this already. The area ID identifies the OSPF area to which network belongs. Even if there are no areas specified, there must be an area 0. If you don't specify any area, it will simply manually write the area 0. All right. So these are the nut and bolts to perform this lab. So let's do the lab. And in lab, I'm just specifying only one area, and the area would be area 0. I will advertise all the networks in single area, which would be area 0. So we already have pre-configured the IP addresses over here, and we need to assign the IP addresses first over here, and over there, and to this machine. And already we have specified the addresses of these machines. So let me assign the IP addresses to our new device. First, I will access this interface, which is R3. So go to your system view and go to the interface view, interface gig 0/0/2. And you need to assign the IP address, and IP address we have specified 2.1.1.1, and the subnet mask is 8. That's it. And at this branch, now this is the branch from your side. Now add your country, Kuwait. So let me go to the interface view, interface gig 0/0/2. And the IP address is 2.1.1.2, and the subnet mask is 8. Okay, go to the interface 0/0/0. The IP address you might assign 192.168.3.100. I'm sorry. IP address, for example, 192.168.3.100 and 24. That's it. And let me remove the default route. Here we have already a default route, so let me remove it first. So undo IP route static 0.0.0 and with mask 0. Okay, I have removed this entry, and just let me verify display IP routing table. You can see the default route has been removed from the routing table, and we need to remove the static route at this side, which we have configured previously. Route static for the destination 192.168.1.0 and /24, and do the verification, display IP routing table. So you guys can see the entry has been removed against the network. So now we are in a position to run OSPF. So we will start from R1. I will take the console of R1. Kindly mute your mic, Imad. So what was the first step? You need to write OSPF, and then I'm putting the question mark, and you can see you need to provide the process ID. And what is the range of the process ID? You can take any number. You can take any number from this range. So I will take simple one, the OSPF process 1. Now you can see the mode has been changed. This is the router view that I was showing you in the early session. So now you need to write, you need to specify the area. That means where you want to advertise these networks. I'm saying I want to advertise the networks in area 0. Okay, now I'm in OSPF 1 and in area 0. In OSPF 1, I am right now in area 1. So I need to advertise the network. And what kind of network I will advertise? I will simply advertise my directly connected interfaces. I don't have to bother about the destination network. I don't have to bother about the next hop. I don't have to bother about the outbound interfaces. I will simply advertise my on directly connected networks, and that's it. So what are my on directly connected interfaces? 1.1.1.1, and over here I have 192.168.1.100. Okay, fine. So network, which network? 1.1.1.1. But if I hit the enter intentionally, I'm hitting the enter. It's not accepting my command. It's saying that your command is incomplete. So how to complete my command? Just press up arrow, space, and put the question mark. What he's asking for OSPF wildcard bits. So these are the necessary parameters. These are not the optional parameters. So I will write 0.0.0 because this is a single IP address. So I will assign all the zeros bits. That means I only want to advertise this specific interface. That's why I'm writing all zeros. Hit the enter, and I have another network on my LAN segment, which is 192.168.1.100 and 0.0.0.0 because this is a single IP address. And that's it. You have run the OSPF. But the thing is, you need to run OSPF on the other two branches as well. And now you can see I have another branch. And at this branch, I have three physical interfaces. This interface, and this interface. Over here, 1.1.1.2. Over here, 2.1.1.1. And at the bottom side, we have 192.168.2.100. So I will take the console of this router, which is in the location. So I will say run OSPF 1, go to area 0 and advertise these three interfaces. One is 1.1.1.2, when wildcard mask is all zeros. The other network 2.1.1.1, wildcard mask all zeros. And the third network, you can see 192.168.2.100. And you can see they have built the neighborship. These are the remarks which I am receiving from my neighbor. And they have completed their state. The full statement, they have built the neighborship. They have built the routing table. They have exchanged the routes with each other. So these are the remarks. These are the states of OSPF. Okay, fine. Now we need to do the same thing on the third branch. And on the third branch, we have two physical interfaces. One is 2.1.1.2, and this one 192.168.3.100. So let me do the configurations. At AR4, at your side, I will run the same OSPF with the same process ID, with the same area, because we are talking about the single area OSPF. That's why I'm writing the same area on all the routers. I need to advertise two networks, 2.1.1.2 and wildcard mask all zeros, and then network 192.168.3.100 and wildcard mask all zeros. And you can see they have built a neighbor relationship.
My dear, can you just a little bit slowly, little bit?
I asked you if someone feel that my speed is very fast. If I'm going with a fast pace, you can stop me. You are going fast.
Just a bit slow down, little bit.
Okay, fine, no problem. Actually, pressure is we have a long outline for today, but the time is very short. So I need to cover all the relevant topics. Although we cannot do that, but still I'm trying to cover all the things. I will go slowly now. I will go slowly.
The configuration, no problem with it. Just so we can revise the just a little bit. Okay.
I understand. No problem. Okay, fine. Why we have done all these stuff? Can someone please explain? Why we are running dynamic routing protocols and why we are advertising routes? What is the purpose?
So at the time there is a downlink because of a static route. The OSPF will do the work, will link again.
Okay, fine. Anyone else,
I mean,
please?
the dynamic link now, dynamic, not static.
Now, so we don't have a static link that we need to define each network exactly with the adding all of the items to the routing table. It will add it for us automatically.
All right.
It will keep the thing much easier for big networks.
Brother, perfect. Please, anyone else? There are a lot of participants, but I'm getting the response from specific people. They are continuously replying.
So instead of putting each destination in the routing table, using it dynamically by the OSPF will make it easier to change the routing table between the routers.
Then perfect.
To exchange, yeah.
Perfect. Anyone else, please? Everyone should participate because that's the time to learn. Otherwise, you won't be getting this kind of circumstances. Yes. Anyone else want to elaborate? No, nobody. Okay, fine. So you people are perfect. You are saying absolutely right. Instead of having the trouble of the destination and the next hop, I'm simply advertising my own networks. This router is simply advertising its own network. This router simply advertising its own network through OSPF. Then they will exchange the LSAs, link state advertisement with each other. They both neighbor will exchange the LSA with each other. And this router will exchange the LSA with its own neighbor because this neighbor has this router has two neighbors, one on the left side and the second on the right side. So the LSA it will receive from its right neighbor. It will add this into its own link state database and then will share all the complete LSAs with R1. And it will create its own link state database. And this, he will exchange its own routes with R3, and R3 will exchange these routes and its own routes with AR4, and it will create its own LSDB. So in order to run the OSPF, ultimately we will be performing the convergence. And what is convergence? Convergence in simple words, convergence means to complete the routing table. And in technical words, convergence means that each and every IP or any destination in your topology is pingable or reachable or accessible. So that's the key target of running the IGPs, any IGP, but right now we are talking about OSPF. So behind the IGPs, what we actually want, we want to perform convergence. And what is a convergence? Convergence means to complete the routing table. And why we want to complete the routing table? So that each and every IP or any destination is pingable or reachable or accessible. Now it's the time to verify. It's the time to verify. Either they have performed convergence. So what should I see in the routing table of R1? Can anyone please give me the details about the routing table of R1? What should I expect in the routing table of R1?
I guess it should have all.
Yeah,
you should go ahead, Yusuf.
Yeah, the VC1,
They both have.
The IP addresses for them.
No, we don't talk about the IP addresses specifically when we talk about the routing table, because router perform routing on the network ID basis, not on the IP basis. Okay, so how many networks I have? 1.0.0.0, 2.0.0.0, over here 192.168.3.0, 192.168.2.0, and 192.168.1.0. So total I have 5 networks in my topology. I have 5 networks. But these 2 networks, this one and this one, these are the directly connected networks. These are the directly connected networks of R1, 192.168.1.0. But these 3 networks, 2.0.0, 192.168.2.0 and 192.168.3.0, I should see them, I should see all of them in the routing table of R1. But these routes are exchanged by OSPF, so I will expect these routes in my routing table through OSPF, 192.168.2.0 exchanged by OSPF, or I'm learning this through OSPF, and 192.168.3.0, it should be in my routing table, but through OSPF. So let's verify. I'm taking the console of R1, and let me remove the screen. There was a mistake to put the password. System view and display IP routing table. And you guys can see, I should be able to see 5 different networks. First, check the direct networks, this one and this one. These were your 2 directly connected networks. I should be able to see 3 routes learned by OSPF. So you can see the 2.0.0.0 over here through OSPF, and 192.168.3.0, I'm learning it through OSPF, and one route is missing, I guess. I'm not able to see 192.168.2.0. No, it's not over there. That means something is wrong. Yeah, something is wrong. Something is wrong. Have you advertised this route? So we need to troubleshoot, display current configurations, the running configurations. So you can see, yes, the mistake is we have only advertised 2 networks. We didn't advertise 192.168.2.0 network or 2.100. Can you see that? So if you don't advertise any network with a network command, it won't be reaching towards your neighbor. So whatever you advertise with the network command, it will be exchanged with the neighbor. But if you don't advertise a specific network, or if you don't want that this route should be shared by the neighbor, oh, okay, you can control that. The networks you want to exchange with the neighbor, you can only advertise these routes. You're getting my point? So what we need to do, again, we will go to the OSPF process, the system view, and the OSPF 1 and area 0. And I will advertise this specific network, which is 192.168.2.100 with wildcard mask, all zeros. And now I would be able to see this route on the routing table of R1. So So I'm running the same command, display IP routing table, and now you can see the seamless exchange of routes. Can you see that? 192.168.2.0 is over here. 192.168.3.0 is over here through OSPF, and 2.0.0.0 is over here through OSPF. And you can see the preference values. All the preference values are 10. And can you see that the next hop is automatically assigned by the protocol? You can see that. Because all the routes, these routes are learned by R1 through which router? Through this router, and from whose interface? From this interface. And what's the IP of this interface? 1.1.1.2. And in static route, we have to write manually this IP address as a gateway, as a next hop. So that's the beauty of dynamic routing protocols. And you will see all the 5 entries in each and every routing table. You can see that values in this router, but here 3 networks are directly connected. Only I will be able to learn this route through OSPF and this route through OSPF because they are non-directly connected networks. So in R3, I should be able to see 3 routes directly connected and 2 routes through OSPF. So display IP routing table. So you can see 1.0.0 is directly connected, 2.0.0 is directly connected, and 192.168.2.0 is directly connected. And 192.168.3.0, this network is learned by this middle router through OSPF. OSPF exchange this route. And the route which is on the left side over here, you are able to see 192.168.1.0 through OSPF. This is called convergence, that you can see the routing table of each device, and you can see every routing table is completed. So
I do have a question.
Yeah, sure.
Okay, you said now that router 3 is directly connected to 3 networks. So how it is directly connected to R1 or router 1? As I can see, it's 1.0.0.0, which is the network address for.
You're talking about this network?
Yeah.
So this is
It's
the
not
directly connected network. Why this is not
to
directly
router 3?
connected?
I mean, to router 3, it is directly connected to the router 3.
Yes, this is directly connected for R3. This is R3. If you're talking about this.
Okay, I thought the last one. Yeah.
Okay, but this network is not directly connected with R4.
Okay. Then it doesn't make sense. It does make sense. Yeah.
Okay, I'm getting through it OSPF.
Okay, great.
I have one question about OSPF. Do you have to apply OSPF on both router or just one router?
But there is noise. There's a noise. I didn't hear clearly. Can you please repeat again?
Yeah, when I configure OSPF on one router,
okay.
Do I have to configure on second router, another router?
Absolutely.
Yes.
If you run OSPF on a single device, and for example, if you are running OSPF over here, but at this side you are not configuring OSPF, so they won't be established the neighbor relationship, and they won't exchange the routes with each other. So this is necessary. If you run the OSPF at one side, you need to run the OSPF on the side so that they can exchange the route with each other. So that is impossible. If you run OSPF at one side and you don't configure the OSPF on the other side, they won't be able to exchange the routes.
Yes, thank you. And I have another question. Do you have to configure like router 1, the gateway of router 2?
Okay.
Do I have to make connection between router 1 and the gateway of router 2? I mean, Gig Ethernet, I think 0.
I'm really sorry. There is quite noise.
We have to. Do we have to connect? We have a static route for Giga Ethernet of 000 of router 2 from router 1.
This router to this router? You're talking about these two routers?
Yeah, yeah.
Okay, next.
OSPF, I mean OSPF enough to make convergence between both router, or we have to make static route to gateway of router 2?
No, OSPF is sufficient to exchange the routes between two devices. We don't need to do anything else.
Yeah, now I got it. Thank you.
Okay, thank you. Okay, that was a single area OSPF, single area OSPF. But this single area OSPF, you can configure in a small size network. Why? Because, for example, if you have a structure like this way, for example, let me draw a diagram. For example, if you have a backbone over here, this is the head office of any branch sector, for example, located in New York. And this this bank has multiple branches on international level. Might be you have another branch in Germany, another branch in Australia, another branch in Kuwait, another branch in, for example, Qatar, and there might be another locations. And then this is the head office, and this is your regional head offices in the different locations. And then from regional head offices, you have multiple branches in the same location. You have multiple edge branches. And over here, again, you have multiple edge branches. And obviously, at this regional head office, you have connected the multiple head offices, multiple end branches. And the same over here, the same over here. So if you have routers like, I'm not asking for the big size network. I'm simply, if I say there might be 100 branches, 100 branches mean 100 routers. And whenever we have 100 routers and more than 100 routers, the single area OSPF, is not recommended. Why? Because in single area OSPF, that means all the routers in a single area OSPF, for example, in area 0. So what will happen? Every router have to maintain the LSDB, link state database. Every router has to maintain the LSDB. And if you have a large size network, definitely you know the size of the database will also be increases. And for example, if any change happens, for example, if you add another branch, another regional head office, for example, in Pakistan, so it will add further branches and they will exchange the LSA, link state advertisement, with the head office, and her head office will exchange these LSAs with every regional head offices, and every regional head office exchange these LSA with all the other branches, it will create a flood. And the size of database table will be exponentially growing. And overall, the convergence will be slow. You will feel delay. The network administrator will start to feel delay. And the size of every router, the resources of every router, the memory of every router will be insufficient, because this is single area OSPF. So what are the recommendations? The recommendation is, if you have a large scale network, a large scale enterprise network, you need to design OSPF in multi-area OSPF, multi-area. You need to configure multiple areas. If you have a large scale network. And if you want to make your network scalable, you need to design your network. If you want to run OSPF, then you need to configure your OSPF by using multi-area designing. Is there any condition for multi-area OSPF configurations? Yes, absolutely. There are two conditions. And what are the conditions? Conditions are, for example, this is your head office. This is your head office, the main branch, the headquarter. Normally, we put this head office into area 0. And in multi-area OSPF, area 0 is called your backbone area. Area 0 is called your backbone area. And the first condition is in multi-area OSPF, there should be a backbone area. There should be a backbone area. And the other regional head offices, for example, over here we have a regional head office in Dubai. Then we have a regional head office in Sydney. We have another regional head office in Kuwait. And we have another regional head office in London. And we have another regional head office in another location. It could be any XYZ location. So all the regional head offices would be connected to the head office by this way. And obviously this is the regional head office, and there are multiple branches which are connected with the regional head office. So you need to put these branches into some other area, You can set area 1 over here, and over here there might be other branches which is connected to the regional head offices of Sydney. You will put them into another area. This might be area 2, and over here in Kuwait there might be other branches, and you will put them into area, for example, 3. And in the same manner, you might have the multiple branches over here. You will put them into area 4, and other branches over here, you will put them into some another area, and that might be area 5. That's a perfect and real life example of OSPF multi-area designing. And the first condition was there should be a backbone area. So we have a backbone area, area 0. And then the second condition was all the other areas. And what we call two other areas, we call them as normal area, or you can call it as regular area. Other than backbone, all the rest areas are called normal area or regular area. Other condition is all the normal and regular areas should be directly connected with the backbone area. So you people can see this area 1 is directly connected with area 0 on the same router, and you can see the area 2 is directly connected with the backbone area. Area 3 is directly connected with the backbone area. You can see over here. And area 4 is directly connected to the backbone area, and as well, area 5 is directly connected to the backbone area. What does it mean? It means that if you connect further 2 branches with this local branch, and if you try to put them into some other area, for example, in area 10, they won't be able to communicate with area 1. I'm not talking about with area 4 and area 3. I'm saying that they won't exchange information with each other, because 2 regular or normal areas cannot communicate directly. They have to go through via backbone. For example, if this branch want to communicate with that branch, so it has to go through via backbone area. So all the communication would be done by backbone. And this is not my design. This is the official design of multi-area OSPF. And what is the key advantage of configuring the multi-area OSPF? The key advantage is if any change trigger, that means if any branch added into some area, it will not be flooded to another areas. You are isolating these areas. All the change, all the flood, if any link goes down, obviously the link goes down, it will impact, it will trigger the SPF. SPF will recalculate the best paths. So this happens only in this isolated area. It won't be impacting to other areas. It won't be impacting to area 2, area 3, area 4, and area 5. You are flooding the, you are reducing the broadcast. You are reducing the flood into the specific area. So you are isolating them. So that the size of LSDB, link state database, would be reduced. Obviously, these routers, these branches will be only having the link state database with each other. Will be sharing the LSDB with each other. They won't share this with this specific regional head offices and other branches. So that's the key benefit of configuring the multi-area OSPF. You can guys ask any question if you have.
I have a question.
Sure, go ahead.
The sub areas that you make now, A1, A2, A3,
yeah,
are they a single area OSPF as its own, not all of this figure? No, just the
yeah,
small.
absolutely. If you talk about this is particularly single area, but this single area is connected with the backbone area. So that's why we have multiple areas in our network. So we are calling it multi-area OSPF. So at its own, this is nothing because it is directly connected with the backbone. If they want to communicate with other branches, they have to pass through via backbone. And it's a single point of failure. You can see on the head office side, we have only seen one router. So we need to add another router for the redundancy, for the backup. And we will connect all the branches with a backup router as well. So it will make very complex. The designing of OSPF is very complex. In the similar way, on the region head office side, we have a single point of failure. If this router goes down, all the branches won't be able to communicate with any other branch. So also we add another router for the redundancy, for the backup. And the backup is also connected with the head office's routers, the service provider routers, the backbone routers. So this is very complicated. The designing of multi-area OSPF is very complicated. But the router with all the interfaces resides in the backbone is called backbone router. The first router with all the interfaces in the backbone is called backbone router. This is the first router type. And the second one, which is located in the middle of the areas, but one interface of this router should be connected with the backbone, and the other interfaces should be connected with the other normal or regular areas, is called ABR, area border router. Look at the name, area border router. That means a router which is at the border. On which border? Where we have areas. So these all regional head offices routers are called ABR, area border router. I hope class is with me.
Can I just ask a question, please?
Sure.
Why cannot A10 communicate with A1?
Which client with whom?
A10, area 10.
Yeah.
It cannot communicate with area 1, right?
Yes, absolutely right.
So I'm asking why.
Why? because this is against the violation of the designing of OSPF, of multi-area OSPF designing. It's a violation. These are the conditions that I have written over here. The condition is there should be a backbone area, and the other condition is all the normal or regular areas should be directly connected with the backbone. So I'm not saying that. This is predefined, and these are the rules of the designing of multi-area OSPF. Okay. So obviously, if you ask why this rule, because the government has implemented that rule. So the developers of the OSPF has designed multi-area OSPF in such a way, if you try to connect two normal or regular areas directly, they won't be able to communicate. It should go through via backbone. So this is the design perspective. This is what my opinion. So over here, you can see the multiple area OSPF structure, multi-area OSPF design. You can see there is a backbone. There is a backbone area, which is area 0. And you can see the other normal and regular areas are directly connected with the backbone. And these routers, all the regional offices are called ABR. These all are ABRs. And what if you have connected with another autonomous system? Because these all designed in a single AS, But if you are connected with another AS and you redistribute or import the routes of the other autonomous system into your autonomous system, then this router is called ASBR, Autonomous System Boundary Router. Autonomous System Boundary Router. For example, over here you can have another autonomous system. If you want the routes of this autonomous system into your autonomous system, then the router which is at the boundary of two different AS is called Autonomous System Boundary Router. All right. So one thing is left, then we will move towards the OSPF, multi-area OSPF lab, and that is router ID. What is the router ID? Router ID is the router identification. And whenever we connect two routers and enable OSPF between them, these two routers recognize each other by their ID, by their router ID. They don't recognize each other with the specific host name. No. They only identify each other by their ID, which we call it as router ID, the identification of router. So how we can select the router ID and what are the parameters? Look at the case 1. The case 1 is if you have a router and you have active and physical interfaces. What I'm saying active and physical interfaces. That should be physical interfaces and that should be active. And the highest IP, for example, 100.1.1.1 is over here and 50.1.1.1 over here. So the highest IP would be taken as the router ID, and the router will do it at it on. I'm not doing that. The first case is if you have physical interfaces, 2, 3, 4, 5, how many number of interfaces you have, the biggest IP, the greatest IP of this interfaces of this router will be selected as router ID. First case. And the second case is if you have configured a loopback interface. The loopback interface is not a physical interface, it's a logical interface, and it is always up. It is always up. So in the presence of loopback, the second case is in the presence of loopback interface, this loopback IP address would be selected as router ID. It doesn't matter, it is a small IP address or a large IP address. And you can see we have the large IP addresses, biggest IP addresses, but on the physical interfaces. But if you have configured the loopback interface, and in the presence of loopback interface, these physical addresses would not be selected as the router ID. The priority is for loopback. This was the second case. And the third case is The third case is if you have a router and you have two physical interfaces and two loopbacks interfaces, loopback 0 and loopback 1. You can create a number of loopback addresses, how much you want. But if you have more than one loopback, for example, loopback 0 and loopback 1, then there would be election, and who will win the election? The loopback which has the highest IP. And you can compare the addresses of loopbacks. Loopback 0 is 1.1.1 and loopback 1 is 11.11.11.11. So this is the biggest IP among the loopbacks. So it will win the election, and it would be elected as the router ID. So we have to rely on the elections? No. If you want to configure at your side, being a network administrator, you want to assign the router ID, then that means I'm the network administrator. I will select the router ID, so you can do that. And for example, I can set the router ID of loopback interfaces. I can set the router ID of the physical interface, whatever you want. So this is called hard code method. Hard code method. If the router ID is configured by the network administrator, it is called hard code method. Is that clear to everyone?
I do have a question.
Yes.
What do you mean by the largest IP address? We will take the first octant and we will compare them. Then we will identify which one is the largest. Which one is the largest, and we will take
simple decimal values, like we say 2 is smaller than 5 and 10 is greater than 5. Yeah, exactly.
Okay, great. So we'll look at the beginning with at the first octant. If it was the big, we'll look which one is bigger, then we'll take it. Then if not, we'll look at the second octant. Yeah.
Absolutely right. Absolutely right. We will focus on the first octet. So now this is a time to perform the lab. So this is the multi-area OSPF lab. So let me draw my on. So what I'm going to do, we will take 3 routers. We will take 3 routers. Router 1, router 2, and router 3. And we will connect them with each other like we have done before. I will take this network over here, and this is pre-configured with /8, sorry. And let me remove this with /8. And 2.0.0.0 over here with /8. 1.1.1.1 over here, and 1.1.12 over here. 2.1.1.1 and 2.1.2. So I will configure the loopback addresses as well. Loopback 0. For example, we will assign 11.1.1.1 with /32. I will assign the loopback on R2, for example, 12.1.1.1 with /32. And on R3, I will configure a loopback IP address with 13.1.1.1 with 32. And also we have LAN segments, and you know what we are running over here. So we have a switch and we have multiple end users over here. So over here, you know, we have assigned 192.168.1.100. Over here, we have assigned 192.168.2.100, and over here, we have advertised 192.168.3.100. All right. And in this topology, I will configure these loopback addresses as a router ID. I will configure it at my on. I will configure all the loopbacks of each device as a router ID in OSPF for the OSPF. All right. And what about the areas? What about the areas? So I will advertise all these interfaces, including loopbacks, including LAN segments, including WAN segments. I will advertise them in area 0. On the other side, including these 2 interfaces, including these 3 interfaces, I will advertise them in area 1. So this is our topology for the multi-area OSPF. That's what we are going to do. I hope this is clear to everyone. So router IDs of the respective routers will be the loopback addresses of each devices. You guys with me?
Yes.
Yes.
You are asleep.
No, not feel sleepy. Already awake.
Okay, this is very interesting topic. I guess the multi-area OSPF lab is very interesting, and
actually,
especially if you talk about designing models.
Actually, I'm waiting for the big topology. I like when things get complex.
So let's do the configurations. But before we jump into the configurations, I need 5 minutes because I need to pray my. I need to offer my Maghrib prayer. I'm already too late. Okay, so just give me 5 minutes and I will be back within the 5 minutes. So then we will start the configurations. Okay, because I'm already too late. I'm already too late. It's been 40 to 45 minutes. All right.
All right.
So give me 5 minutes. Okay, I will be back after 5 minutes, inshallah.
Inshallah.
Okay, guys, let's do the configurations. So already we are running OSPF area 0. So I need to remove that first. So how can you remove the hosts by simply saying undo OSPF 1? And okay, yes, fine. We want to remove all the configurations. And now you can see display. Yes, yes.
Yeah, we will remove the the configuration from all of the routers or only from router 2 and 3.
Yeah, we can do that, but for you people, I'm doing that. So I can do that, but for you people, I'm going to start from scratch. All right.
Oh.
You might be expert, but there are some people and they have just started the networking. So everyone should be on the same platform. Undo OSPF 1. That's it. We have removed all the configurations. You can check your routing table. You can see there is no entry through OSPF, and you can verify from this display current configurations. This is really very important command, display configurations. So you can see we're not running any OSPF process over here right now. All right. So this is our topology, and I cannot show you along with the configurations. So okay, can I take the picture? Okay, guys, you need to remember the configurations. Let me close these configurations. I want you to see the configurations and the topology level. Okay, so let me draw the design over here. We have loopback over here 11.1.1.1. We will define the loopback over here 12.1.1.1 and then 13.1.1.1 over here, and we will configure them as router ID for the OSPF. And we need to advertise all these interfaces in area 0, 1.1.1.1 and 1.1.1.2, and the both loopbacks and this interface, which is 192.168.1.100. I will advertise them in area 0, and these interfaces, including this interface, I will advertise them into area 1. So what are the interfaces? 2.1.1.1 and this interface 192.168.2.100, and this interface 2.1.1.2 and this interface, which is 192.168.3.100 and this particular loopback. All right, so let's start the configurations. Okay, starting from R1, we go to OSPF1, but before jumping into the OSPF1 process, I will configure the router ID, but we didn't create the loopback interfaces. So you can see how we can create the loopback interfaces. So interface loopback 0, and you need to assign the IP address, which we have decided 11.1.1.1 and the 32 subnet mask. And the same configurations I need to do on the other routers. So R3, which is our middle router. So I need to create a loopback, interface loopback 0, and I will assign the IP address, for example, 12.1.1.1 with /32. And /32 means all 255, because we are only configuring a single IP address as a loopback. So that's why I'm putting /32. Okay. And on this device, so I need to configure the loopback 0. You can create loopback 1, 2, 3, and 4, whatever you want. So IP address, for example, 13.1.1.1 and /32. All right. Now we will start from R1, and from R1, I will do the configurations of OSPF. So OSPF 1 and the router ID should be elected according to my choice. So that's why I'm putting the router ID along with the OSPF process, and that's it. And then obviously you need to go into area 0, because over here we will advertise them into area 0. So that's why I'm writing area 0 over here. And what networks? I'm starting with the loopback 11.1.1.1.1 and wildcard mask all zeros. Then your WAN interface, which is 1.1.1.1 and all the bits are zeros. And your LAN segment, which is 192.168.1.100, and the wildcard bits, because we are talking about a single IP address. That's why I'm putting wildcard mask as 0. Okay. This is all about the configurations of OSPF at R1. If you want to see what you have configured, you can run the command in the same mode, display this. Display this means whatever I have configured over here. So you can see the commands which I have given at this interface. I just put the area 0 and advertise these 3 networks. 2 are physical interfaces and 1 is the loopback. All right. Okay. Then we need to access the second router, that one. And over here, I will do the same thing, but carefully, but be careful because we need to assign one loopback, this loopback, and this physical interface. And this interface, excuse me, Imad, please unmute mute your mic.
I have questions.
Sure.
Loopback for route 1 is 11.111 or 1111?
No, it's 11.1.1.1. It's 11.
So why we put network and F as 1111? There is one network 1111.
No, we have defined this IP address with /8.
Okay, now I get it.
And I'm defining this loopback with /32. So it will decide. Okay, fine, thank you. Okay, so I need to run OSPF, but while running the OSPF, I will configure the router ID for this router, and which is 12.1.1.1. And then I will go to area 0. And in area 0, I have only 2 networks. I have only 2 interfaces. One is your physical interface and one is your loopback. You can see my border line. Including these 2 interfaces only. Okay. So I need to advertise 2 interfaces. One is my physical interface, which is 1.1.1.2. And the other one is 12.1.1.1. And that's it. I need to put the wildcard mask as well. Okay, fine. But now, by sitting at the same router, I need to jump into area 1 because right now I'm in area 0. Because I need to advertise these 2 interfaces in area 1. So I should change the area. According to my topology. So you can quit from this interface or you can simply write area 1 over here. So simply write area 1 and you will see in this mode the area has been changed. Now you are in area 1. So whatever, I'm really sorry. Okay, I guess we have done almost. So network, which network? 2.1.1.1 with wildcard mask all zeros. And the network, the loopback, no, not the loopback, the LAN segment, 192.168.2.100. And wildcard mask all zeros. That's all about R3. And now we need to run OSPF on this router, AR4. So all the interfaces in this router, we have to advertise in area 1. So OSPF 1, OSPF 1, and you need to configure the router ID 13.1.1.1. And then the configuration succeeded, you need to restart OSPF process. Okay, fine. So you need to go to area, which area? Area 1 and network 2.1.1.2 wildcard mask all zeros. Then the loopback 13.1.1.1 wildcard mask all zeros. And the network, which is the LAN segment 192.168.3.100 with wildcard mask all zeros. That's it. We have configured multi-area OSPF in overlap. So how we can do the verification? For the verifications, obviously, You will go to R1, for example, and in R1, I will simply check the routing table. Either all the entries is populated, display IP routing table, and you can see all the networks over here. This is the directly connected, and this one is directly connected. These two are directly connected. Now you can see this network that was over here came through OSPF. This network over here came through OSPF, and 3.0 over here advertised by OSPF. As I told you, that was area 0, and this was area 1. And the router, I called it as area border router, because I told you we call area border router to a router which is having at least one interface towards backbone and the other interfaces towards regular area or normal area. This kind of router is called area border router, and he is the responsible for the communication between them. So can we see that anywhere? Can we see that anywhere? Yes, we can see. Where we can see, you simply need to write display OSPF. Display OSPF, okay, fine. Or you can write brief, okay, fine. And here you can see that here what he has written, area and border router. That means your R3, this one is area border router. And if you want to see the peers, the neighbors, so you can also verify that by giving the command display OSPF peer. You can see a huge information. We can convert into a brief. So display OSPF brief. And you can see that this router is saying, I have two neighbors. I have two neighbors. One on this interface, the other one on this interface. This neighbor belongs to area 0 and this neighbor belongs to area 1. Can you see that? Can you see he is telling you the neighbor ID, the neighbor identification is 11.1.1.1. But at this side, he's saying that the neighbor ID is this, which is wrong, because we have configured this as a route ID 13.1.1.1. But if you remember, while I was configuring the router ID, it gave me a notification. Yes, over here. It gave me the notification, but it has been removed, that you need to restart the process of OSPF so that your new ID, the new router ID becomes a router ID. So for that purpose, we need to restart the OSPF process, but nothing is much more important right now at this point. You should see the routes, and you see that this ABR, area border router, is maintaining two kind of databases. One for area 0 and one for area 1 and one for area 0. That means the area border router has to maintain two databases, one for area 0 and one for area 1. And it will keep the separate of both of databases. All right, it maintains the databases separately. Okay, guys. Till that, is there any question?
Yes, I do have a question.
Yeah.
Why we have a loopback? IP address, or we have done that.
I was waiting for that question, that what is loopback, why we are configuring loopback. Okay, that's a good question. Okay, let me explain. For example, if we have such a topology, for example, such kind of topology, and we are connected all the devices like this way, and we are running OSPF, and for example, OSPF 1 with area, for example, with any area, with area 0. I'm having 1.1.1.1 over here and 1.1.1.2 over here, then 2.1.1.1 over here and 2.1.1.2 over here, 3.1.1.1 and 3.1.1.2, 4.1.1.1 and 4.1.1.2. And also I'm configuring the loopback addresses, and this is your important question, why we are configuring loopback. For example, this is 11.1.1.1 and this has loopback, which is 12.1.1.1, and this has loopback 0, which is 13.1.1.1, and this has loopback as 14.1.1.1. Like we are running OSPF, and OSPF build the neighbor relationship, the peer relationship with its neighbor, with its peer. For example, if this is R1, it will build the neighbor relationship with R4 and with R2. All right. If we talk about these two neighbors, if they build the neighbor relationship interfaces, if they build the neighbor relationship, if they identify each other with the physical interfaces, then what will happen? What could be the loss? If this link goes down, their neighbor relationship will be brought down as well. They will break the neighbor because the link has been gone. But what is the advantage by establishing the peer relationship, the neighbor relationship through loopbacks? Keep remember one thing, I told you the router ID means the identification of a router. Router 1 knows its neighbor, that means router 4, by its router ID. If I'm configuring this loopback as a router ID, that means R1 will identify its neighbor by this loopback, not by this physical interfaces. And if this link goes down, what will happen? This R1 will reach towards its neighbor by this way, because the loopback interfaces never goes down until unless this router goes down, because these are not the physical interfaces, there is no link. So whenever you establish the neighbor relationship through physical interfaces, at any time this link may goes down. So what will happen? Obviously they will break the neighbor relationship because the link has goes down. But if you have configured the loopback addresses and you are running any protocol on the basis of loopback addresses, you are configuring the router IDs of loopback addresses, you can reach that neighbor by an alternate way. You got my point?
Yes.
That's the key benefit of configuring loopback addresses and configuring them as a router ID.
So it's a backup.
Yeah, it's a backup. It's a backup. If this link goes down, then obviously you won't be able to reach this network, to reach to that router. So the loopback addresses are the addresses. The loopback interfaces are the interfaces which never goes down. So that's why you don't build the neighbor relationship by using the physical interfaces, so that you can reach that neighbor by an alternate way. Because when you run the OSPF, you will see this loopback will be advertised on R1 on its route table, either this way, either this way. If this link goes down, OSPF will change the path. OSPF will change the path. I hope this is clear to everyone. That was a good question. That was a good question. I appreciate your question. At least you are running your brain that why we are configuring loopback addresses and why we need them, why we are configuring them as a router ID. I guess the rest people are in sleeping mode. They have loose and courage. They were very excited, but now I guess
we are not sleeping. We are listening. Focus.
I guess your link has goes down.
Maybe.
Okay. Okay, guys. Let me take the attendance. Let me take the attendance. Because this is necessary to take the attendance of few people. All the time they ask for the attendance. Where is the attendance? Who was there? So we need to take the attendance. Okay. Before your session, I was having another session for the same ICT quiz competition. So thank you guys. So I have an assignment for you people. If you people are interested, if you ask me to send us an assignment so that we can have a best practices on OSPF. So I have two assignments, one for single OSPF configurations, the other one is multi-area OSPF configurations. Multi-area OSPF configurations and the learning objectives, configure a specific router ID, which we have done, and configure the multi-area OSPF. And you can see this design. This is quite simple, like we have discussed in our lab. So you can see this would be your topology. You may fit any other router between them, or you can place a switch over here. You can place a switch over here. If you place a switch over here, you need to use the same network over here, and over here. And there you have the multiple loopback addresses, which you need to configure as a router ID. One of them you need to configure as a router ID. And you will be having all the command, all the configurations, all the steps, what is the scenario, and how you will do that, task, step 1, what you have to do on R1 and what you have to do on R2 and R3. You have all the steps along with you. So I'm giving you that as an assignment. Already solution is there, but still this is your assignment. So everyone has to send me this assignment in the WhatsApp group. If you are interested, if you want to learn professionally and extraordinary, so you have to do that assignment. So any question, guys? I'm still have a lot of things to discuss regarding OSPF, but I guess for today's it's quite sufficient because I cannot hear any voice from your side. I know some of them are very tired. I guess
actually
my opinion.
It was very interested and satisfying at the same time.
Yeah.
Yeah.
Very informative. Thank you so much.
Yeah, we are not sleepy, but we are quiet to hear, to understand and focus, but not feeling sleepy.
Yeah,
that's why you were quiet. That's why you were quiet. All right.
Okay.
So you were,
regarding
you were listening very deeply.
Yeah.
Not talkers.
Actually,
okay,
regarding
that's good. That's good.
The assignment, we can deliver it by this weekdays. You can send, double check it.
How you want the flexible time, whatever you find, it's up to you. I'm not saying you need to send me right tonight because I'm not your university professor.
Yeah.
So I will not ask send it me tonight. Whenever you find flexible time,
yeah.
So you can do that, but try to do that.
Oh, okay. Thank you.
Okay.
Okay, sir. You will share the assignment in WhatsApp group.
Yeah, definitely. After the end of this lecture, I will send both of the assignments. One is for single area OSPF and the other one is for multi-area OSPF. So do both of the assignments. It's a good practice. It's a good practice.
Sure, sir.
The assignments and all the files also, sir.
All the files, I have already sent you 2 files which we have discussed, and the rest are for the assignments. I will send you that files as well. What kind of files? What kind of other files you want?
For the coming days.
For tomorrow's lecture?
For tomorrow and for next week, there will be also a PowerPoint slides, right?
Okay, I guess you have a lot of time.
No, I mean
you don't have any other engagement.
I mean it's better to send it from now, so you don't have to send
no,
it.
No problem, no
time,
problem. I will send it to you people. No problem, no problem.
Yes, please, because we need to print it out and